So we've done the results of the 20-meter sprint and the comparison of that, and here we have the results of our vertical jump that we did, and we measured the peak power and the comparison of the heights. So on the left hand graph you have the peak power in the vertical jump, where it has my performer, the better performer, and the NBA elite. So my performer got around 3,600 watts. The better performer got around 5,700 watts, and the NBA elite player got around 8,200 watts. So you can obviously see at the start that the NBA elite player has a much higher peak power in the vertical jump, which is not surprising, as that's what they train to do every day. They train to increase their power in order to block shots, dunk, and just and get some rebounds. So, however, for my better performer and my own performer, they have a lot less watts than the NBA elite player. However, my performer has the lowest of them all, and this may be because of their body mass. Their body mass may be quite light, as peak power is the body mass times the jump height. So that may be a factor. They may not be that position. So my better player may be a centre, where he's made to get vertical jumps to get rebounds, whereas my performer may be could be a shooting guard or a point guard, so they may not be able to get as higher watts. Therefore, they would need to increase their power, as this will give a huge advantage on increasing their vertical jump, and therefore it will make a bigger impact in their game, which could overall make them perform better, get higher rebounds, get higher blocks, and get higher dunks. On the right hand graph we have the comparison of the vertical jump heights, where my performer got around 71 centimeters, the group average was around 79, the NBA elite player got around 98, and the better player got around 80 centimeters. So my performer is the lowest, below group average, and the better player, which needs to improve, and therefore this could be because of their power, as their power is a lot lower than the other. The better performer, the better performer is more likely going to get a higher vertical jump, as they can get a bigger reaction force off the ground. And in order to improve this, they may have to try and improve the way they jump. They maybe improve their technique, and it will make a huge impact on the game, as the height of the vertical can really affect your team's performance, such as getting rebounds and starting a counter attack. Therefore, as you can see, my performer is a lot lower than the rest. Therefore, it needs to improve due to them factors. When it comes to the numerical model, there are advantages and disadvantages. Firstly, the advantages of the numerical model are the actual results that get carried out. These can be significant in changing players' performance, as it gives them a good idea if they're perhaps too slow and they may need to get stronger or improve their stamina. It is a very objective model, where there is data and people just go off that, and there isn't much subjective analysis, which can be quite good. It is also very simple to carry out, as most equipment used does the work for you, and it just carries out all the calculations you need, and all you need to do is put it in the right place. However, that could be a disadvantage, as you do not know the right setup, and you do not put it in the right place, and the results may be very inaccurate, as the setup of the data collecting is very strict. Another disadvantage is obviously the price of the equipment. Equipment such as the tightened gates and force plates are very expensive as well as high quality cameras. So not that many analysts would actually be able to carry out the data due to the high price. However, if they can, the numerical model is a great way to look at basketball players' speed, acceleration, and stuff like that.